reflex arc, and reflex action. What are these? A reflex arc is the nerve pathway taken during a reflex action. Meanwhile, a reflex action is a quick, involuntary, or automatic response to a stimulus. During a reflex arc, the pathway, the nervous message goes to the spinal cord, and the message then passes from the spinal cord directly to an effector to give an immediate response. Now, what are these reflex actions? Take, for example, sometimes you might have put your hand on a hot stove. You didn't know it was extremely hot. By mistake, you put your hand there. Before you know it, your hand comes up to you before you even know it. Now, there are two things that could have happened. When your hand is on the hot plate, it's either you think about it and make a decision to remove your hand, or you remove your hand before thinking about it and making a decision. So two things. It's either you remove before thinking, or you think before removing. I don't know which one you will choose. But surely, I'm sure if your hand is on that hot stove, you will start going like, oh my Lord, my hand is on the hot stove. I think it's burning. Must I remove it? Yes or no? What do I do now? You won't go that way. Okay? So you will say quickly, before you know it, you see your hand is already up. Then you start thinking about it. What is then the use for these reflex actions? It is to prevent the body from sustaining extensive damage. Or, on the other hand, otherwise, it helps to reduce the amount of damage that will have been incurred by the body. Okay, there's already some damage, yes, but let's not make things worse. That's exactly why a reflex action is important. So let's see how this actually operates in details. This is how our reflex arc will then look like. In this diagram here, you should be able to identify a cross section of the spinal cord, a finger with a pain receptor that we have here, a muscle which will act as our effector. So we have cross section of the spinal cord, finger, pain receptor, and muscle, our effector. Looking at the cross section of the spinal cord, we should be able to see the dorsal root of the spinal cord, the back, and the ventral root of the spinal cord. We should be able to identify white matter in the spinal cord, which is outside of gray matter, which has an H shape. Now remember, in the cerebellum and the cerebrum, gray matter is outside to form the cortex, while white matter is inside to form the medulla. In the spinal cord, we have the reverse of this arrangement, with gray matter inside forming an H-shaped cortex and white matter on the outside. Again, we will identify 3 neurons in the spinal cord. We'll identify the first one here. I'll call it neuron F. I'm going to call this neuron F. My neuron F is the sensory neuron, or the sensory nerve bundle. And my second neuron, this one here, will be neuron A. That will be my connector neuron, or the relay neuron, the relay nerve fiber. That will be my A. The third one, so this is my A here. The third neuron will be this one here, and I'll call that neuron B. That will be my neuron B. It is the motor neuron or the motor nerve fiber. So the three neurons. Notice then that the sensory neuron has a nerve end, the receptor. The receptor is involved in picking up changes in the environment. And these changes, since they bring about a response, these changes are referred to as stimuli. In this case, it is a pain stimulus because the finger is resting upon a small pin sharp enough to cause pain. So the way the reflex arc operates, let's look at it. The receptors of the sensory neuron, is the way you must say it. The receptors of the sensory neuron pick up the stimulus, which is pain. The stimulus is then converted to an impulse, and it travels along the sensory neuron, passing through the dorsal root of the spinal cord, where it makes contact with the connector neuron in the spinal cord. The impulse is then transferred from the sensory neuron to the connector neuron. The connector neuron then transfers the impulse to the motor neuron, which transfers the impulse through the ventral root of the spinal cord and to the effector, which is a muscle. In this case, since we are looking at the finger, the hand will have to all go up. So our effector most probably will be the muscle of the bicep. The biceps, that will be our effector. So in this case, the instruction will be to tell the biceps to contract, and the bicep will contract, the triceps will relax, such that the hand together with the finger is all lifted up very quickly, automatically. It takes milliseconds, we don't even realize it. Now, so when pain receptors, I take again, pain receptors pick up pain, and the stimulus is converted to impulse by the sensory neuron, transfers the impulse right through the dorsal root to the connector neuron. The connector neuron then transfers the impulse to the motor neuron, which transfers the impulse through the ventral root, and to the effector, the response is executed. That's what happens. One thing I want us to notice here is the fact that, again, when we're looking at the connector neuron, neuron A here, my neuron A lies only in the spinal cord here. That's where it lies. Remember that question. Which neuron is found only within the central nervous system? Our answer is the connector neuron, because the spinal cord is part of the central nervous system together with the brain. So, usually, they will then ask you the questions. Explain what will happen if say neuron F is damaged. Explain what will happen if neuron F is damaged. Let's damage neuron F a bit. Let's try to cut it out. See? Here, my neuron F is cut, it's damaged. And I'm sure we can see that no impulse can be transferred through that gap there. Okay, we've damaged neuron F. So then, out of 4 marks, explain what will happen to this person. And to get these 4 marks, we'll have to speak about the sensory neuron, which is neuron F, and the motor neuron. which is neuron B. So I have there my neuron F, which is a sensory neuron, and the motor neuron will be neuron B. Explain what will happen to the person if neuron F was damaged. We will then say, if neuron F is damaged, now I'm talking about the sensory neuron, and I'll have to score 2 marks on that explanation. If neuron F is damaged, first thing to notice here is that impulses will not travel from the sensory neuron to the connector neuron because of that breakage there. So the sensory neuron will not convey impulses to the connector neuron. That is 1 mark. Secondly, it means the person will not feel pain. Those are already 2 marks. Only on the sensory neuron. Now I go to the motor neuron. The question is, if impulses are not sent to the connector neuron, do you think the motor neuron will receive impulses? The answer is no. So, with the motor neuron, I will say impulses will not be received or will not travel through the motor neuron. That's already 3 marks because that one is 1 mark. It means there will be no response. That is 4 marks. Because it's only when the motor neuron carries impulses to the effector that we have a response. So then that makes my 4 marks. Impulses don't travel through the sensory neuron to the connector neuron, 1 mark. No pain is felt, 2 marks. Impulses don't travel through the motor neuron, 3 marks. No response is executed, 4 marks. That's what happens. Now, otherwise, the question could change. And now you have our neuron F is all fine and working. And you are then asked to explain, what if it was neuron B this time that was damaged? Let's see. If we now damage neuron B, what will happen? It's cut there. In our explanation now, it will change. We will then say, when we look at neuron F, the sensory neuron here, neuron F is working very much perfectly. So we will then say, the sensory neuron will transfer the impulse to the connector neuron. That one is fine. 1 mark. The pain will be felt this time because the sensory neuron is working. 2 marks. Impulses will not be transferred from the connector neuron to the effector. 3 marks because the connector neuron has a damage there. It means there will be no response. 4 marks. So in this case, sensory neuron is working. Impulse will be transferred from sensory to connector. Pain will be felt. Motor neuron is damaged. Impulses will not be transferred from motor neuron to effector. That's 3 marks already. No response will be executed. 4 marks. So that's how you score those 4 marks either ways. Now, again, when we look at the direction of flow of impulses, you could also be asked the question, list out the sequence of flow of impulses through the reflex arc that you have in front of you. It means my correct sequence will be from F. F is sensory neuron, to A is connector neuron, to B, and my B is my motor neuron. That's a sequence. If I had to include other things, maybe this part here, the pain receptor is, let's say, X, and my effector is Y, it means my sequence will be from X to F, F to A to B, and B to Y. Please, I'm showing it this way so that we don't go on, because sometimes we are super intelligent. We just want to write everything in alphabetical order, and then we'll have A, B, F, X, Y. Okay, so there's that sequence of flow of information. That's the direction. And if we then consider this sequence, we will notice something. It goes more or less, if I have to summarize it, it goes this way and curves and comes back. In that direction, it goes back. If we consider this section here of what I've drawn here, if we consider just this section here, it looks more or less like an arc, the arc of a circle. And that is why this pathway, since it forms an arc, that is why we call it the reflex arc. Okay. So that is how our reflex action or the reflex arc is presented. I've included this slide here so that we can all enjoy some aspects about the reflex action and normal actions that are under the control of the wheel. Here is a normal action under the control of the wheel, the action of looking and then picking up, looking at and picking up a glass. Okay, we decide to do that. But with the reflex action, we have no decision to make. We just execute it quickly. Now, what then happens actually? I have two paths here. I have one that goes from the receptor and through the spinal cord and back. I'm going to call that path A. And path A is my reflex arc. Yet I have another path here that also goes from the receptor and to the brain, most probably the cerebrum, and to the effector. I'll call that path B. So in summary, this is what I'm having. I have a path from any part of the body there. Let's say that finger comes here. My spinal cord will end somewhere there, and it goes back to the effector. Okay, that is my A. Or I have another path that comes also from there, but this time it goes right up there and then before it comes back down. That is my B. If you were to check the distance traveled by path A before it comes back to the effector, or by path B before it gets back to the effector, then we will notice that with path A, the distance is shorter. Okay, we'll see that the distance in path A is much more short. Meanwhile, the distance in path B is much longer than that. It means we can ask ourselves then, which one will require more time to cover? Obviously, B will require more time to cover. And very funny enough, this more time also means more time for your hand to burn. Okay, I'm sure we start seeing where we're going to. So, can we rather take a shortcut to reduce the time for your hand to burn so that extensive damage can be avoided? That's why we'll be using path A, which is ending within the spinal cord. It ends there and goes back. Very short road. So that is exactly what happens. Spinal reflexes end up with the spinal cord and go back to the effector so that we directly execute the response. Now, there is also a catch there. Understand that the spinal cord doesn't have any major higher thought centers. To put in lay terms, we can just say in lay terms that the spinal cord doesn't think. It doesn't make any decision. It doesn't have any judgment or memory, or doesn't store experience. It just acts. Okay? So then, if we recall these moments where we withdrew our hands very quickly to avoid extensive damage, at one point it came to our mind later on, we asked ourselves the question, but what happened here? I see my hand is up. What actually happened? And after that, we now realize what happened. And we then make the decision to not do it again. Look at where decision is coming. Under the brain here. There's no decision here. Okay. We then make the decision of not doing it again. Why? Because we have memory of what happened. We have experience of what happened. But the spinal cord is not capable of this. It then means that something else has happened apart from the spinal cord being in control. What happened? While that message, the impulse, is sent through the spinal cord, while it's sent through the spinal cord, so that we execute an action, that's our message going through the spinal cord, then we execute that action. While that happens, a small copy of this same message goes to the brain. That's a small copy of the same message that goes to the brain. So before it reaches, this one reaches the brain, the first one must have arrived here already, because again, like I said, this road here is longer. This road is longer than this other road here. Okay. So while this first message is sent and the reflex act is executed, the small copy that goes to the brain serves as to instill in you memory, judgment, decision-making, experience, so that you tell yourself, after you've done this, oh, I now see what has happened. I understand. I decide now I won't do it again. I won't go back there again. Because, as weird as it sounds, since the spinal cord doesn't have such high processes, if that message was not sent, if that small copy was not sent, and we were to consider only this little message that is sent here, if we were to consider just this one, this is what will happen. You will have your hand on a hot stove. Yes, spinal reflexes are still functioning. You will withdraw that hand very quickly. But because you can't remember what happened, you can't have memory, because you are now dealing only with the spinal cord and not the brain, because you can't remember, you will eventually go back there and withdraw again, and go back there and withdraw again and go back there, until people will start thinking that now your spirits are dealing with you, your ancestors are not happy. Okay, so you will keep on doing that up and down until you start confessing. Good. So to avoid that, that is the reason why the nervous system has made it mandatory that while the spinal reflex is executed, which is very, very important, we've seen why, a small copy of that same message should then be sent to the brain so that you don't do it again. So I think this should conclude the spinal reflexes or reflex actions or reflex act.